Today, graphene has attracted widespread attention and also represents a huge potential for various scientific and practical applications due to its physics-mechanical properties. Graphene is characterized as a 2D sheet of sp2 hybridized carbon atoms located in a coaxial lattice. One of the important processes is the synthesis of graphene. By synthesis of graphene is meant to obtain graphene of desired size, purity, crystallinity using various methods. In this case, the most commonly used methods for the synthesis of graphene are mechanical splitting, epithelial growth, chemical vapor deposition, electrochemical peeling. Figure shows the different methods for the synthesis of graphene. To obtain graphene by the method of mechanical splitting, thin layers of graphite are placed between adhesive tapes and the graphite films is cleaved of time after time until the thin layer is obtained. The next important method is epithelial growth of graphene, where graphene is grown on monocrystalline silicon carbide. In this method, silicon carbide is heated under a temperature of about 1200 Celsius degree under vacuum, resulting in the sublimation of C atoms, forming carbon layers on C carbon, which can be double layer, multi-layer, or monolayer. Synthesis of graphene in the CVD method carried out directly on next transition metal substrates such as nickel, copper, cobalt, aurum, and ruthenium. Also, the process of saturating carbon carried out under the influence of next various gases, hydrocarbons, methyl, ethylene, acetylene, and benzene at high temperature. There are differences between CVD process with hot and cold walls. That substrate in the hot wall is heated by radiation from the heated chamber walls, and the temperature is relatively constant everywhere because the chamber is heated by an external sources of energy. In the cold wall reactor, the sample is heated using the following ways: passing current through the sample using a heater of substrates using induction, and the chamber walls have room temperature. The next method of obtaining graphene is electrochemical oxidation of graphite. Choose the electrodes and electrolyte, one of the important processes in the electrochemical oxidation, which affects the increasing in charge transfer and the functionalization of obtaining graphene sheets. Many different electrodes and electrolytes are used for this method, and most commonly used electrodes are graphite, copper, platinum, and the next electrolytes H-brom, H-hor, HNO3, and H2SO4, as well as acid electrolytes and alkaline electrolyte, Kali-OH diluted with distilled water, which is ideal for oxalating graphite. In this process, two graphite electrodes or other types of first inserted into the solution. Then about 10 volts is applied to the electrodes, and the intercalating ion of the solution penetrates between the graphite layers and exfoliates into a few layer graphene sheets. After separating graphite particles from the graphene, the solution is exposed to centrifugation and ultrasound to improve the exfoliations. To finish the process, the solution is right. Thus, until today, the synthesis of graphene and graphene-like materials is relevant due to the unequal physical mechanical properties. Moreover, many works aimed at finding ways to obtain graphene under such conditions as low cost, fairly simple synthesis method, scalability, and capabilities turn into graphene. One of the most appropriate methods for the synthesis of graphene, given the above conditions, is to obtain fullerene, which will be discussed in subsequent sections of this work.